Okay, this playlist will be composed of a number of short, approximately 10-minute videos where I'll go through examples of each of the things that we're going to need for our test. The first thing that we're going to look at is using Venn diagrams to determine validity or invalidity of direct inferences. So suppose we have a direct inference like this. Premise, conclusion. Our premise says it's not the case that all countries are countries that recognize Crimea's annexation. Our conclusion, thus some countries are not countries that recognize Crimea's annexation. The first thing we're going to do is write a premise diagram and a conclusion diagram. So with our premise diagram, we label it premise. Then we take a major word in our subject class. In this case, C for countries is the only word in our subject class. We label the left-hand circle, the subject circle, with that letter. Then we take a significant word in our predicate class, in this case annexation, and use that first letter to label our predicate class on the right-hand side. We do the same thing for our conclusion diagram. So now we've got a premise diagram and we've got a conclusion diagram. When we start with the premise diagram, the first thing we're going to want to notice is that it's got an "it's not the case that" clause. And so the premise itself asserts that a standard form categorical statement is false. Specifically, all countries are countries that recognize Crimea's annexation, a universal affirmative statement. Our premise says that is false. Now we could go to our premise diagram and put in what would have to be true in order for this whole premise to be true. Or we can do it in a more stepwise fashion. We can start off by symbolizing what it would take for this standard form universal affirmative statement to be true, and then figure out what we would have to put in our premise diagram in order to get our premise diagram to be a representation of what it would take for the entire premise to be true. That is, the universal affirmative statement would be false. So we'll start off with that true diagram. That true diagram says, here is my country circle. Here is my countries that recognize Crimea's annexation circle. I'm just looking at this universal affirmative. I'm in Boolean, so I say I don't know if there are any C's. I don't know if there are any A's. But what I do know is that nothing that is a C is outside of A, because everything in C is an A. Everything in this circle would also be in this circle. Now there may not be anything, but if there is, it's going to be an A. And so this area, C and only C, the part of C that's outside A, that has to be empty in order for the standard form categorical statement to be true. So we know that in order for this standard form categorical statement to be true, the one that's embedded in our premise, C and only C, this area in our diagram, has to be empty. It's shaded. If we want to make our whole premise true, our premise asserts that that standard form categorical statement is false. And so we look and say, okay, what do I need to make it true? I need this area to be empty to make it true. If our premise says that it's false, to make our premise true, I'll have to make sure this can't happen. And so I'll add an X to that area so that it can't be the case that this area is empty because it has at least one member. So now we've got our premise diagram. Our premise diagram tells us what has to be true in order for this entire statement to be true, our premise. So now we look at our conclusion diagram. Our conclusion diagram is going to tell us what our conclusion needs in order to be true. Some countries are not countries that recognize Crimea's annexation. So now we've got a particular negative statement. A particular negative statement can be understood as saying there's at least one thing. It has this property. It's in that circle. It does not have this property. It's not in that circle. So it's inside of C, but it's outside of A. And so we put an X in C and only C, that area that is in C, but outside of A. And that's what we need at minimum for this particular negative statement to be true. So here's what we need to make our conclusion true. There has to be at least one thing. It's a country. It's not a country that recognizes Crimea's annexation. Here's what we are guaranteed to have if our premise is true. There's at least one thing. It's in C. It's outside of A. So we say I need this, at least one thing that's in C outside of A to be the case in order for my conclusion to be true. If my premise is true, it guarantees that that's the case. And so my argument is valid in Boolean logic. Now, the reason why we always start testing in Boolean logic is because if an argument is valid in Boolean logic, it'll be valid in Aristotelian logic as well. So once we get that verdict of valid in Boolean, we can also write valid in Aristotelian or valid in both logics, because now we know it's going to be valid in either interpretation. Let's try another example.